Welcome to section 8.5, Solving Radical Equations. Now, this is our final section in chapter 8. And notice we're transitioning. All of our other sections in chapter 8 have been simplifying, multiplying, adding, subtracting. They're on expressions. There's no solving for a variable. Now we're going to solve for a variable. And to help you, I have a little review I want you to start off with. And that is this. So I want you to first multiply out these x minus 2 quantities squared. Go ahead. First, hopefully you remember that this is x minus 2 times x minus 2. You can distribute, and you get x squared minus 2x plus 4, or x squared minus 4x plus 4. The big key step is this thing right here. Remember, squareds don't distribute to the individual things inside. You have to rewrite them and multiply them out. All right, now with that in mind, I want you now to square this. Go ahead. Again, you can rewrite it, or you can remember that a square root is actually something to the 1/2 power, which means I'd multiply these exponents, which would give me 1, so it's just 2x plus 1. In other words, a square root, remember saying what number squared? Well, so a square root is the opposite of squaring something, kind of like if you add 5 and then subtract 5. They just cancel each other out. So this is just the opposite of what we've been doing with square roots in this chapter, is to square it. So if you square a square root, the square root goes away and I'm left with exactly what's inside. Okay, now finally I want you to solve this equation. Go ahead and pause the video and solve it. All right, well, the only method we have for solving quadratics is to actually factor it. So as you factor this, you can break it up, that middle term, because you've multiplied numbers that multiply -4 are -4 and +1. Factor by grouping, and you end up with x plus 1 and x minus 4. Once these are factored, remember to set each factor equal to 0 and solve them, so we end up with x equals -1 or x equals +4, and indeed that's just our final answer. So this whole process of factoring by grouping, squaring numbers, solving by factoring, etc., are now all going to be tied together. So let's do some actual examples of solving a radical equation. So we're going to start with a basic one, where I notice I have a square root, a radical, is equal to a number. In this particular case, I can look at this and go, okay, well, the opposite of this, I want to get to that x. Well, the only way I can get to the x is getting through this square root. So I got to make that square root go away, which means I have to square both sides. Well, if you square this side over here, remember what's going to happen. Hopefully you're saying it's going to make the square root go away, and I'm just left with 3x plus 4. That's nice. Well, 8 squared is 64. Okay, let's just solve for x. Go ahead and pause the video and solve for x. Welcome back. As you did that, you subtract 4 from both sides, and then you divide by 3, so I get x equals 20. And you seem like you're done, but you're not. In all these problems, just like when we solved rational equations, you need to check your answer. So we plug it back in, and I get 3 times 20 plus 4 and the square root of all that. So 3 times 20 is 60, and 60 plus 4 is 64. Square root is indeed 8, so 8 is equal to 8. Good. Our answer checks out. Our answer is x equals 20. Well, let's try this one. Again, I can't just automatically square root. The first thing I'm going to want to do is I'm going to get the square root all by itself. So can you get the square root all by itself? Subtract 7 from both sides. Now, what would I do to get rid of that square root? Hopefully you're saying I can square both sides. If I square both sides, notice what's going to happen on this side as I square it. Let's just leave them with x minus 1. Negative 5 squared is 25. Okay, add 1 to both sides, and x equals 26. So let's check our answer. And I get 26 minus 1 underneath the square root, which is 25, okay, which gives me 5 plus 7, which can, 12 does not equal 2, therefore no solution. So we got to make sure that whenever we check this, if our answer does not check out, that we have to throw it out and move on. With that said, there are going to be times that you're going to get multiple answers. You can get up to 2 or more, depending on how big the radical is, but you could have 2, you could have 1, you could have 0, so be prepared and always check your answer. Let's move on to another one. This, I want to solve it. Now notice now I have an x, but the idea still continues the same way. We need to, because we want to get at this x underneath the square root, the only way to do that is to get the square root all by itself. So how can you get the square root all by itself? Hopefully you're saying I can add x to both sides. Okay. Now, I want you to go ahead and pause the video and solve it like we've solved the last couple by squaring both sides. Go ahead. Welcome back. So if you squared both sides, notice the left-hand side is just going to give you 6x plus 7. Again, going back to what we said earlier in the video, how do you square x plus 2? Well, I write it as x plus 2 times x plus 2. I can then multiply it out. And I'm just going to kind of, you can do FOIL, you can use distribution property. We're going to multiply it out, and I end up with 6x plus 7 equals x squared plus 4x plus 4. Well, let's just kind of reset at the top. So let's put that back up here. And I want to solve that. Well, how are you going to solve something that has an x squared in it? Well, going back to what we did at the end of chapter 6, remember, I have to get everything equal to 0, and then I can factor. So if you got to this point in time and stopped, that's okay. So I want you to set everything equal to 0 and factor it. If you did do that, just go ahead and let it keep running. So we can subtract 6x from both sides and subtract the 7, and we end up down here as x squared minus 2x minus 3. And you can factor that. You can break this up into minus 3x plus x and factor it by grouping, and you end up with x minus 3 times x plus 1. So this, and you can check that multiplies out to here if you want, but we set each one of those equal to 0, and I end up with x equals 3 or x equals negative 1. So I have two answers. But again, just like the previous two situations, we cannot just walk away. We need to check both answers. So let's start with x equals 3. Let's plug it in. And if you didn't do this, I want you to pause the video and keep going from this point in time to check not just the rest of x equals 3, but check x equals negative 1. Go ahead. All right, so on this, I have 18 plus 7 minus 3 equals 2. And 18 plus 7 is 25. So that's 5 minus 3 is 2. 2 is 2. That's good. We really like that. To check the other one, plug in negative 1. And notice when you subtract, it becomes plus. So I end up with 1 plus 1 is 2, so 2. And voila, all my answers are correct. So I get two answers out of this one. Now, just a quick comment before I stop the video and go to the second part. On these problems, I want you to show your checks. I want you to show all of your checks as to what you're doing to make sure that you understand that that's a vital part of every one of these problems. So make sure that you show your checks. Good luck, and make sure you go to the second part of the video as they go through more examples about how to solve radical equations.